Okay, so here I have a question where I can use Pythagoras to solve for a missing side length in a right angle triangle. Now remember, to be able to use Pythagoras, I have to check that I have a right angle triangle to begin with, and I do, as we can see the right angle right here. Now usually a right triangle is identified with that square in the angle. If you don't have the square, you have to look for the number 90, or maybe in the problem it's going to tell you you're dealing with a right triangle, because if we don't have a right triangle, we cannot use Pythagoras. So when do I use Pythagoras in a right angle triangle? Well, when I'm given two side lengths, which I am right here, 4 centimeters and 5 centimeters, and I need to find the length of the third side, this one here with the x on it. So Pythagoras said that I have to label the triangle with side lengths A, B, and C, where C is always the longest side. And that longest side is always across from my 90-degree angle. So this side I'm going to call C. The other two sides get called A and B in any order. So I'm going to put A there and B there. So it's obvious to me now that the side I'm looking for is side C. That's the one with the X on it. I know side A, it's 5 centimeters, and I know side B, it's 4 centimeters. Now there's three variations of the same formula for Pythagoras. If I'm looking for side A, I would use this one because the A is by itself. If I was looking for side B, I would use this one because the B is by itself. But what I'm looking for is side C. So I'm going to choose the one where the C is all by itself on one side of equals. So I'm not going to use this formula, and I'm not going to use this formula. This is the one I need. So if I rewrite it, c squared equals a squared plus b squared, just so I can line it up more easily. And I know I don't have a value for c yet, so it'll just remain c in the formula. Instead of writing a, I'm going to write 5, because that's the measurement I was given. And instead of writing b, I'm going to write 4, because that's the measurement I was given. Following the order of operations, the next step is to square both of the known values. So 5 squared gives me 25, plus 4 squared, or 4 to the power of 2, which is 16. So c squared equals 25 plus 16, which is 41. And notice here I don't have c isolated yet, which means I don't have an answer for c. What I have is c squared equals 41. I have to get rid of this squared. And to get rid of squared, I have to do the square root. Whatever I do on one side, I do on the other. So here, I take the square root of c squared, which will leave c by itself. The square root and the squared cancel out. But if I do square root over here, I've got to do square root over here. So c is equal to square root of 41, which is 6.4. And that was in centimeters. So the side length c of my triangle is 6.4 centimeters. All right, here I've got a second example where I can use Pythagoras to help me solve. So let's label the triangle and figure out which one I need to use. Now I know that the longest side is always called C. The longest side is also always across from the 90-degree angle. So I'm going to put C here, and that's my hypotenuse, or longest side of that right triangle. Sides A and B can go anywhere I want them. So I'm going to call this one A, this one B. And now I can see that the missing side, where the X is side B. So I'm going to use this formula right in the middle here. That means I don't need this version, and I don't need this version for this problem. So if I'm solving for side B, and b squared is equal to c squared minus a squared, then b squared is going to be equal to 15 squared, because that's the measure for side C, minus 12 squared, because 12 is the measure for side A. Now I can't do anything with the b squared yet, so I'll leave it. 15 squared, I need to apply that exponent, so 15 squared is equal to 225, minus 12 squared, 12 to the power of 2 is 144. Now I'll combine those two values, so b squared is equal to 225 minus 144. That leaves me with 81. And that's the value for b squared, not for b, which is what I'm really looking for. So to get rid of that squared, I need to take the square root. Taking the square root on this side gets rid of the squared here, but if I do it on one side, I have to do it on the other. So I'm going to need to take the square root of 81 to get a value for b. And the square root of 81, if I hit the square root button, I get 9. My measurements were in centimeters. So side B measures 9 centimeters.